Good morning, everybody. So we're just going to give it a few minutes. I see people coming in. Ooh, you're popular, Alex. So I guess to some degree we've had some of this conversation as we're waiting for this to start. But Alex, I do need to just talk about your location for us. I think that's the first time that we're having a tech cast from a location like that.
I hope so. I mean, it's I'm sitting in a car on a wingback chair for reasons. So my kids have an event tomorrow morning in school, and we put this chair in the car already. And I'm in Potsdam right now. That is close to Berlin in Germany, at a conference, and I had not enough time to go back to the hotel, and now the lights are going off. That's good. So this is a little bit different, I would say, and maybe the first time that someone is streaming from a wingback chair in a car.
Yeah, I have to say it's certainly my first. Anyway,
It looks cozy.
That's nice here.
Speaking to German folk, this reminds me of the German bakery that I used to frequent in Herrenberg, and we were just talking about that. And it's now, 11 o'clock on my morning in the east. I know it's evening for most of you, and certainly Tau is our on another continent altogether. So we've got Europe, we've got the Americas, and we've got Africa. So anyway, I think we've got some people coming in. Shall we make a start? If we can just obviously, I'm here with Dr. Alex Willner. We're doing a session on from imagery to interactive 3D maps, outline global with CISS and Oracle Cloud. So this is a session I've been looking forward to. In the room, we have the esteemed Hans Viehmann, and then Karin Patenge. If I'm saying that correctly, hopefully.
You are.
Okay. They've come along, Hans and Karin. Karin's actually been very instrumental in developing this, I understand. So we have the A team sitting in the background ready to answer questions. And while I talk about that, if you do have questions during this, please don't put them into chat, put them into the Q&A. So that's just one bit of housekeeping. So with that, let's move on to the next slide, sir. All right, Tau.
Yeah, thank you. Thank you, Roger. So good morning, everyone. Good day, wherever you are watching us from. So for this slide, we want to remind you that we have enormous amount of collateral, and all the videos and slides, as we get them, they are added almost immediately after the presentation. You can also watch them on YouTube, and we're always looking forward for good abstract. So if you go to our website, andouc.org/testcast, you will see the archive there, the past and the upcoming TechCast. You will see them. The one we are having today, which is November 13th. The next one is December 11th, and also the next one is January 8th. So we encourage you to submit your archives for the webcast as well. So that's what we have here as well. Thank you.
Thanks, Tau. Yeah, just so what we're looking for is obviously anything Oracle, analytics, and data. And if it's cutting edge or you're doing something particularly clever, we're always very keen to expose that to the community at large. So just ways to connect with us. We're obviously on LinkedIn. We have a category specifically for spatial and graph on LinkedIn. We're now at we're on Blue Sky as well, but probably my favorite of all of these, and this will be posted with the presentation, is Slack. You'll find all sorts of people hanging out on our Slack channel, including a lot of product development. So it can be very useful if you've got questions or you wanted to get some general knowledge. Next slide, sir. So important, save the date. One of our favorite things to do is to meet in person. And our summit this coming year in 2026 is from April 14th to the 16th. Please do have a look at your calendars and have a look at your travel. Get your business cases going. If you need help with a business case, we actually are going to be posting something on the website to help you with that. But we have some amazing keynotes speakers, and we also have access to some senior product management who generally attend the event because it's right in their wheelhouse, next to, it's actually right in the neighborhood in Redwood Shores. So please do come. We'll just remind you about this date at the end of the session as well. So next slide, sir. And I think it's back to you, isn't it? Let's see. Yes. So
Yes, it seems so.
it's getting there. So with that, the rest of us are going to go off screen, and we're going to leave you to the mercies of Alex. And in the background, we have the A team who will answer questions. We'll also, if there's things that we think are going to be better in a live situation, should we have time at the end, then we might re-ask some of those questions for Alex and Hans and Karin to answer at the end. But with that, I'm going to hand over to Dr. Alex Willner. Thank you so much for being with us today.
Thank you very much, and well, good evening from my side. The morning is long done, and well, let's dive into the topic just right now. Yep. So if there's only one thing to remember, let it be that I would say usability is what transforms information into insight. This might be the headline for the presentation today. And well, let me tell you why. So as I said in the beginning, I'm sitting in a chair here in a car for reasons. One is being that I'm the father of 3 wonderful young children. And as any parent knows, you sometimes find yourself, let's say, volunteering for school events. And I think it was May last year when I was asked to take, if I could take some photos and videos of a school performance. And of course, I obviously agreed, and it was a lovely event full of energy and emotion and, of course, a lot of proud parents. And afterwards, I faced a familiar problem. How actually shall I share all the recordings, several gigabytes of photos and videos with the other parents? I mean, fortunately enough, that's rather simple nowadays. One click in my photo library, and everything is available through iCloud in this case, with previews, embedded videos. So very easy sharing experience. And as someone whose whose heart beats for making data useful, and well, I even did for this reason, I did my PhD in information modeling. I find that really remarkable. So simplicity hides the amount of complexity that we have in the background of this overall process. And I would say in our professional lives, things might be a little bit different. At my company, we work with others that manage large amounts of spatial and imaging data. And about a year ago, we met Outline Global. That is a company that operates its own national aviation fleet. They capture imagery, LiDAR data for the clients, covering vast areas of Australia. And well, after each flight, there are several terabytes of data need to be processed and delivered. And the clients must download, inspect, evaluate, approve, and sometimes reorder datasets. So a little bit different to my example at the beginning. And much of this still happens in the old-fashioned way. So that means through FTP servers, shared drives, manual file handling, and well, I think you can imagine that what that means. Slow, unstable transfers. I hope this network here is not going down while I'm talking. Different file formats, versioning is certainly a problem. And overall, it's a process that doesn't match modern expectations of usability and accessibility that we know from my iCloud example. So this was the starting point, and we set out to change all that. So this was a great effort together with Outline Global, Oracle, and CISS TDI. And the goal was clear. We wanted to build something like an iCloud for aerial and geospatial data generated by Outline Global. And so we want to have a single platform where clients can log in, explore the projects, preview data, open 3D previews, download exactly what they need without any special software installation, technical setup, and whatever. And the system of all was designed in mainly 3 parts. Also develop different technologies. You might heard of SvelteKit, Geo3D, maybe not, but OpenLayer certainly, 3JS. Also some technologies in the front end and typical software libraries like Fast API, Celery, Untwine, GDAL, PDAL, and many more in the back end. And all of this was deployed in an Oracle Cloud Infrastructure tenant just for this client with an Oracle Autonomous Database, I think 23 AI. Hans might know a little bit better. Map Viewer and Spatial Map for the OGC services. They all did the hard work for the generating the raster, hierarchy building, and so on and so forth. And the question is, how does all look like? Yeah, so good that you ask. Let's have a short look what we have. So I'm going to have a live demo of the setup, but let's start with a couple of screenshots to onboard you to the process. So what we see here right now is a screenshot of the map with some meta information of the different layers that we added. So here, for example, boundary and a couple of key value pairs, because at the end, the client is going to download the whole data set, and the client wants to know where, in which area to find exactly which information. Then we have vector data and 3D data. Here's an example. It's LOD2 data that is actually generated from dense LiDAR point clouds. So they did the flyover and then generated the LOD data that we're going to see on the map later on as well. Imagery, of course, so higher resolution than the typical base map. And of course, you can also get the different endpoints, OGC endpoints, and other endpoints to access the data that we have in the Oracle database directly. So here, as an example, we have the imagery data with direct access and in QGIS, in QGIS here via OGC services, WMTS this is this example, but we do have other OGC services for other data as well. What is always nice to have a look at are the point clouds. So we converted the data into cloud optimized point clouds with multiple detail levels for elevation, intensity, color, and classification. You can access this data directly in QGIS, for example, as well, via direct HTTPS. And what else do we have? Digital elevation model. So a 2.5D digital representation of the service. The example data that I'm going to show in a couple of minutes are actually not there. There are not too many mountains, but there are other larger rocks in Australia. So let's have a live demo, shall we? So I prepared a little bit for this. So you might recognize what we're seeing here. This, of course, is Australia. And we do have a couple of data sources imported for the client. So as a starting point, you can search for different layers. So RGB information, for example, or what else do we have? Let me have a short look. They're all LiDAR data. Elevation models, metadata, and point clouds in this data set. Of course, we can also select a couple of other projects as well, filter by capture dates and the accuracy that you're interested in. So let's start because we don't want to have a look at
Alex,
Australia.
Alex,
We go to CAS. Yes.
Sorry, things are breaking up quite a bit. Maybe you want to just try turning off your camera for a little while, see if it works better.
That's unfortunate. Yep. Let me.
Thank you.
Yep. Thank you for the heads up. Okay, so let's start looking for Castlemaine. This is here in the lower right corner. The starting point is, for example, the boundary of the mosaic. So, yep, basically we're here at Castlemaine. It has a very specific area that is currently not visible. I hope my network is not breaking down. Let me add another layer here as well. Give me a second. Here we are. Okay. So this is the area that the client ordered, or this example data is covering. And what we can actually see is also some metadata about the different layers. So what kind of layer do we have? Capture dates, history. Of course, if you want to go back in time, the services and APIs to directly integrate the data into your local system. And let's keep a little bit by the vector data. So as an example here, we have the building footprints. here we are. Let's zoom a little bit closer. And maybe this building over there, this looks quite interesting. We could gather a little bit more about metadata here. So we are in the file for Castlemaine. We have the different property and values that you have seen on the screenshots, the different rasters, and where to find the information in which files. And then the third layer that we have just enabled are building footprints. So here the footprints are LOD2 data. And interesting, maybe it's generated in 2019 by CAD mapping from dense lidar point cloud. So this is where this vector data is coming from. And maybe we want to zoom a little bit further and have a look at what kind of building this is. So here we have imagery of the base map that we have added. So let's zoom a little bit more and see what kind of buildings this is. Yeah. So unfortunately, the map data is not available with this zoom layer. But fortunately enough, we do have our own RGB layer that we can add here. So what's now happening in the background is that the imagery from the flyover is being loaded, and then we can zoom way closer to this building and analyze it. We can also move the layers a little bit. So here we are. So this is nice. So we can zoom way closer than we could with the typical map. What else do we have? Anything more? Yep. So let's see. I'm going to add another layer in the background because this takes a while. This is this one here. While it's starting to load, we can work a little bit with this layer. So we could, for example, have some measure tool. Let's see, okay, this is 14 meters wide and roughly, what is the area? Yeah, 300 square meters. Up is the area. We can modify the shape a little bit. I mean, what you would expect from a map. And what's loading in the background right now is are the point clouds. Because this takes a little bit more time. I already prepared something in another tab. So imagine the point clouds have been loaded. No, now it's loading. Let me see where we are. Here we are. Classification, full resolution maybe, and remove the other layers. And now what we're going to see right now are the cloud optimized point clouds with the classification. And of course, these information is also very interesting in being viewed in 3D. We have a 3D button here as well. So all this information that the client requested has been processed and stored into the database. It went through a couple of ETL pipelines, and then we added dynamically the endpoints for this customer. And the customer can actually nicely pan around, zoom in, work with the data, get the meta information of what we have here, and yeah, basically evaluate if this is exactly the data that the customer is interested in. The last layer that we might have is, let me see, the elevation model. Let's put the elevation model here as well. So what we now see here is a 2.5D visualization of this area. As I said, okay, this is not iris rock, but there is still some small heights that we could climb, but certainly not the highest mountain in Australia. As I said, all this information is accessible via endpoints, or most of the information at least. I did prepare a little bit about here in QGIS. Here's QGIS. So here we are in Australia again. We know the city here is the lower right corner, and here we are. Over there, we just added the endpoint for the imagery. And now we can zoom in here a little bit in my GIS. Let's see, maybe here I can exactly see who took my parking lot in, I think, in September 2019. So this is another live demo on how to work with the data that we have added to the database. I could pan around and zoom and have a look at the system for many hours. But we might want to talk a little bit about the technical details, what we did in the background to enable all this. Yeah, I did prepare a backup video because I was not that sure about the network here, but this, I think, worked out well enough. So let's have a brief look at what made all this possible. So the platform itself, as I mentioned before, runs on an Oracle Cloud infrastructure built together with Oracle experts. And we use an Oracle Autonomous Database with auto-scaling to serve the spatial content through a WMTS and vector tile services. So this is basically what you see here on the right-hand side. So for this project, we decided to initially process mainly the 2D data, the 2D vector data and 2D raster data through the Oracle database, and use Map Viewer and RDS to provide the APIs. So the large imagery and vector data sets are stored in the Oracle database, and we also do have the LIS and GeoTIFF files. So we have a second ETL process in parallel to this. For this, we are using the Oracle or an Oracle object storage and a couple of worker nodes in the OCI to import elevation information and the loss files, pre-process them, and then make them directly accessible through an HTTP2 endpoint. So this overall architecture, and in particular because it's running in the OCI, ensures a lot of scalability and reliability for the client, and rather secure access. I mean, there are way more components on top of this. There is a secure gateway and other services that you would expect in a professional cloud environment. But all this is actually the key requirements when you deal with the national scale geodata like we did with Australia. And everything basically follows open standards, making it rather easy to integrate it into other workflows and GIS systems, as I demonstrated. And I mean, this is a good starting point. As I said, I think we started a year ago-ish. Now it's online. The first customers are really using it, and we're all proud of what we have implemented. But this is, of course, the starting point of the whole endeavor. So beyond that, there are way more ideas how we could evolve the platform. So we have a strong foundation, works quite nice. And we have mainly three big areas of ideas where we want to improve. So one is, of course, these spatial ML algorithms that we have in the Oracle database for analysis and prediction of geospatial data. We do have Hans here in this call who did a great presentation, I think a month ago or so, going more into the details about the analysis, correlation, regression, and classification, of all what you could do within the Oracle database. One of the reasons why Outline Global has chosen to run all this on an Oracle infrastructure. Another point that we have not yet implemented, but is certainly of high interest, is the actual geometric intersection. So what you have seen was the preview of the data, of course, in your specific bounding box and the hierarchy based on the zoom level. But at the end, the client is going to download the whole data set and then work on the files. And one of the next steps is to do geometric selection, then on demand just cut out this specific information, this specific layer in a given file format that you need for your next steps. So what the client is actually needing. So often the client does not need the whole data set as it is. And I mean, in this use case, Outline Global is paid for doing flyovers, and this overall process of ordering new flyovers is a manual process. This could certainly be integrated into this portal as well. I mean, this is what we're doing with other customers already, where you just create your geometric selection, then order a flyover. And yeah, so let me close by returning to our initial idea. The goal was to create an iCloud for aerial and geospatial data. In this case, data generated by Outline Global to be consumed by their clients. And I mean, whether it's family photos or terabytes of LiDAR data or whatever you are doing or your own clients are doing, the challenge is always more or less the same. You have a lot of geospatial data, you want to share them, use them, make them accessible. At the end, you want to turn information into something accessible and, well, meaningful, right? So this is why I started this presentation with that it's usability, what transforms information into insight. This is one of our steps towards this direction, and I'm certain that there are other clients, other companies with similar challenges. And well, we do have a nice starting point, and we could have a talk about this. We might have a couple of questions already in the chat. So, but I am not the person who did all the work. So I'm just here today.
Or maybe
A great
we'll
team. So Ronald and Karin. Sorry.
No, sorry, Alex. We came on because you're sort of coming to an end. But I think if we just turn our cameras off and turn our microphones on, that might work better because it just suddenly killed your bandwidth. So okay, we're off. You should be able to speak again now.
I bought a couple of gigabytes of traffic, of mobile data, but it certainly was not enough. Okay, yeah. So thank you very much for in particular to Ronald and Karin and all the others for making this possible. Yeah. So I'm keeping my video off.
Yeah. We do have one question.
Let's have a short look at what. Yep.
Yeah. So we've got one.
Go ahead.
We answered one question already, but there's one open, and it's from Amin Adatia, and he says, "Are there better features in Oracle 26 AI for mapping?" Yeah, because what you were talking about was within 23. And then, Karin has said she's going to answer.
Yeah, well, so I would ask first, what are better features you're looking for mapping?
And while
So
I mean
question
is
to Amin.
while I mean is thinking about what could be better features, maybe one thing which we could already say at this point is that we are continuously rolling out new functionality for map visualization. One of the things which Alex briefly mentioned, but maybe not everybody sort of got this, is that he's built the visualization on top of the capabilities in the database to create vector tiles straight in the database. And we're extending that to also generate raster tiles from straight within the database. And sort of future plans are to also do 3D data in the same way, such that you can use the scalability of the database to generate the relevant vector tiles which the mapping client can natively consume, so that you don't need any kind of middleware in between to render the content and send that across to some client, which not only reduces the number of moving parts in this architecture, but also makes it very scalable and fast. You'll see that being picked up, by the way, by the Apex colleagues in the next release. So the Apex map region is hopefully, if all goes well, right, it's planned functionality which is not out yet, but they're planning to release support for vector tiles. So that's 2D and vector for the first step with the next release. And then you can see how that works in your Apex environment. Not sure if Amin wants to expand on the question. Maybe he can
I
add to
add
that.
something
Yes, Karin, go ahead.
Something specific for that project. What you might not have seen or recognized is that the user front end you've seen here is actually an Apex application. And by the time of developing the Apex application, which was part of the project or working packages of Auric Consulting in Australia, by that time, we didn't have this integration of natively consuming vector tiles generated from the Oracle database in Apex, which will be released hopefully with the next release. So the integration will become even easier to consume vector tiles, and maybe in the future, hopefully also raster tiles.
Thank you very much, Karin. There's another anonymous question. How was the overall performance of the outline global geospatial data system been? How has it been?
That's a very
Maybe Alex
generic
wants to,
question.
yeah, maybe Alex wants to comment on that, from his experience. I don't know, Alex.
I'm not sure about this question. Maybe you can rephrase it a little bit, or how you actually understood it. I mean, we did evaluate a couple of different front end libraries. So for example, usually you are using Cesium for this kind of visualization. But then we did some measurements, and then we decided to use Geo 3D for the front end. I mean, we do have the network access to the data stored in the OCI. I mean, network-wise, this was very performant. We did have a challenge because we were working in Europe, and this OCI tenant is located in Australia, so there was a little bit more delay from here to there. But I mean, the target group is obviously in Australia. But overall, I mean, given that there are terabytes of data that we had to process and then stream through services and the HTTP pipelines, we are certainly very satisfied with the overall performance, the ETL pipeline and the front end interaction.
Yeah.
It works quite well.
Maybe to add some insights about what we did in terms of optimizing the performance for the user or the graphical user interface, which, as I said, is an Apex application. So with regard to working with the vector data, we used the vector type creation inside the Oracle database. It's provided by the package SDOUtil, and there is a function called get vector tiles. And there is additional optimization to creating those vector tiles by caching the vector tiles inside the database. And that's what we also used in this project. So this is the part for vector data. As for raster data, I mentioned already when I answered the question, the first question, that the raster data are stored inside the Oracle database, and from those we created we generated WMTS services for the raster tiles, and the images or the tiles that form the actual maps, those are also cached on the map viewer or the middle tier part in that architecture, so that we use different caching mechanisms to get a good performance when visualizing the data sets in the Apex application.
Right, and it's probably worth mentioning. Yes, go ahead, Alex. You want to go?
Sorry, one point to add. We also had a load balancer in front of this Oracle database. So we had 2 instances of the map viewer, for example. I think 2 or 3. No, we had in this project we had 2. But talking about scalability, we could also have used 3, 4, or 5 of them. Yep. So performance-wise, we just also did some. We had 2 of the map viewers and a load balancer in front of all the APIs.
Maybe I can answer the next question by Amin. How easy was it to import spatial data? The CISS TDI developer, whose name is Ronald, he did a very nice job in actually creating templates for the different types of data. And the actual data then were imported using the open source tool GDAL. So it depending on the data format that was loaded, we added the right parameters to the GDAL calls in order to import the data directly into the Oracle database, either as for vector data as SDO geometry, or for raster data as SDO georaster. So this was part of the whole processing workflow of importing or pre-processing data, importing data, and then doing some post-processing, and afterwards also publishing the data and creating the endpoints for the visualization.
And all of that is completely transparent to the user, right? So the user selects, oh, I have whatever, 2 terabytes worth of GeoTIFF.
Click it's automatically
and upload.
Scanned and extracted the different types of data sets and the different files belonging to with their formats, and then extracting piece by piece and processing and loading it into the database.
Mm. Yeah, I mean, this is basically what you're doing is uploading a large tar file with any kind, or let's say a large list of geospatial data types, but plus meta information. So we used a JSON LD description file to give a little bit more context to the different files. So when was it recorded? And other meta information that might be of interest. Should it be available through an API or not? So one part all the deviations, but the metadata is important as well. And we did this by describing it using a JSON LD file. Before this, the customer used an Excel sheet to store this information. But we decided that Excel might not be the best file exchange or information file format.
Yeah, and there is another question: how large were the images used? I recall that we, in the test or in the development and testing phase, we worked with RAS or imagery data between 250 and 500 gigabytes. I'm not sure whether in the production environment they have even larger raster imagery. So this could be the case. So yeah, that's kind of the order of magnitude.
I think they
Super.
do. This was the demo or the test data that we had to implement the service. But
Yeah.
of course, they're getting more and more data more or less every day.
Yeah.
Right, and it's probably worth mentioning that, and that also goes back to the question about performance. Unlike sort of a classical GIS system, you're not downloading the 500 gigabytes worth of data to a client, but the customer can actually select the part they're really interested in, and that you just render what is required, so that you can only extract the relevant parts, which of course is way faster than operating on huge files in total, right?
So
Good. I mean, if I can, I actually also have a question to Alex. I don't know if you could answer that, but one of
Here it comes.
the things which I was I was wondering was, do you know what a typical customer of the system would be, and maybe also what they usually would do with the data in terms of, you know, business process, business workflow?
Yeah, I would say any kind of company that generates geospatial data, in particular large data sets, imagery, lidar data, is a potential customer of this system or a user of this system. I mean, could be someone who's doing flyovers with drones, or it could be satellite data. It could be, well, anything that at the end it generates image data, 3D data, point clouds that has to be streamed or should be streamed to customers. So the possibilities are huge.
Okay, great. Okay,
Yeah.
so for example, if I was a utilities company, and I do a flyover of all my transmission network in order to see vegetation growth in and around my network or something, that would be the kind of contract that Outline Global would fulfill, or maybe, I don't know, open pit mining, looking at the landscape. Is that's the kind of thing which they typically do, right?
Yeah, that's a good other example actually, because the flyover for a railway company, for example, they're using this information internally. Of course, you could certainly, as a utility provider, use such a system internally as well. So in this case, Outline Global is more yeah, it's they're hosting this data for their clients, and I could imagine a utility provider would host something like this for their own data sets. I mean, these are two different kinds of use cases.
Mm-hmm. Okay, great. So that was the one question I had. The other one was, you briefly mentioned in passing that all the data ends up in an autonomous database. Can you expand on why the customer chose the autonomous database? Is that something they share with you, or was it just a given?
It's it's more or less already the decision at the beginning of the project. The two main reasons I recall are the scalability on the one hand side. I mean, if you have a autonomous database with all the scaling and an OCI infrastructure, I mean, you could put as much data into as you like. So this was certainly one aspect for the decision. So you don't want to host or manage this kind of infrastructure your own. So wonderful if Oracle already has these capabilities. And the other one is here on the left-hand side, where you gave a presentation also about the last months, is they wanted to use the AI capabilities of the database to add further information or to analyze the data and provide their customers again a little bit more insights of the data. So it's not only about the flyovers, it's not only about the point clouds, but it's also to get insights out of these huge amounts of data, and they don't want to reinvent the wheel and reuse what's already there. So these are the two main reasons I recall.
Okay.
Very
Sorry.
good.
Yeah,
Okay.
maybe I can add another reason or other reasons as well. So one was, of course, that the core business of the customer is in creating and providing useful, meaningful spatial data to their customers. Their core business is not in doing all the IT stuff and putting together the infrastructures that are necessary to make those applications available. And that's why we decided to have everything in the Oracle Cloud on OCI and use as much as possible fully managed cloud services. And this is the case for the autonomous database, especially. And yeah, and another reason for that was also to use the latest features that were implemented with Database 23 AI as much as possible. And there is ongoing activities and also using the new features around AI, using vector search and those kind of things. And that was also a reason why they decided very early on to use the autonomous database.
Okay, great. Thanks, Guy. And Alex.
Thank you so much, buddy. We're sort of coming up. Is there anything more? Did I see you wanted to say?
Yeah. There is more question, but maybe, Amin, if you don't mind, would you please reach out to me regarding your specific questions? We've had similar projects, especially with monitoring vessels that are not allowed to enter certain areas. So this is something we've done with at least one other customer, or myself has done something similar with another customer. So yeah, I just suggest to reach out to me directly.
Okay.
Thank you, Karin.
Yeah,
Appreciate
this
it.
style, I just want to add some of other use cases that I've also worked on based on the spatial technologies. So for instance, for some of the questions that were asked about what other things can be gotten from Oracle Spatial. So there's a use case around trying to understand who are the people that are withdrawing money around ATM. There's ATM location, which customers are withdrawing from certain ATM location as well. So if it is the customer from a different bank is going to a certain ATM to withdraw money, you can also, we've analyzed that in the past. Also seismic data for oil, rig, for crude oil. So we've loaded for the person that also asked the question around the amount of data. Seismic data is very huge. So we were also able to load this into the Oracle Spatial Database as well to also understand where they can easily drill as well, and also location intelligence around COVID time, while COVID was spreading, while Ebola was spreading, where they have all these health issues. So it was tracking it in real time globally, not just in a certain country. And this was used by Oracle Apex and Oracle Spatial Database that was used at that moment. So there are lots of use cases around Oracle Spatial and how you can integrate to other GSI platform as well. Thank you.
Thanks, Tao. All right, as we get to time, I think just really one more reminder. Thank you so much, Alex, for presenting. Can we just go straight to the summit slide, which is, I think, that one. Really, if to see these sorts of things, I don't know, Hans, if you're going to be there this year, but there's usually a gang of product management there. We have some really interesting sessions. We're busy evaluating content at the moment, but we've got way more abstracts than we needed for this session, so I can promise you it's going to be of an excellent standard and well worth your while to come and join us. So with that, I would like to again just thank all our panelists and my co-host Taiwo. Thank you very much for joining today. Do a great job. And
Thank you.
with that, we will say goodbye and thank you, Alex, one more time. Much appreciated. Have a good day.
Thank you.
Have a good night.
Yeah, thank you, everyone.
Thank you very much for your time.
Yeah.
Thanks, Alex.
Okay.
That was great.
Thank
Yeah.
you.
Thank you.
Bye bye.
Thanks.
Have
Bye-bye.
a nice day, everybody.
Bye.
Same wise.